In this video, I will explain you about Earth's magnetic field. We know that Earth is giving out magnetic field. I will explain you about the reason why Earth produces magnetic field. But what is the proof that Earth have magnetic field? Thing is, we can simply keep a magnetic needle freely hanging at any surface of Earth. We will see that the magnet will rotate itself and will get aligned in a particular direction, and that is nothing but the direction of magnetic field at that position. So Earth is producing, or Earth is giving a magnetic field. Clear? Now we know that Earth is rotating at every moment. Earth is rotating about its own axis, and this is the axis which we call as the rotation axis of Earth's rotation, and this point is considered as geographic north and this point is considered as geographic south. So geographic north and south is nothing but two extreme points in and the axis of rotation of Earth. So this is the axis of rotation of Earth, the red marked one, and this is geographic north and this one is geographic south. Connect it, we will get the axis of rotation of Earth. So this is geographic axis. Okay, we will simply call it as geographic axis. Now we generally have a perception that the magnet is pointing towards the geographic north of Earth, but actually it is not happening in that way. It is happening to this magnet is pointing to a different position. This is nothing but magnetic north of Earth. I'll repeat it. When we are hanging a magnet, we have considered that this is pointing towards the geographic north, but actually it is pointing towards magnetic north. These points are far away from each other, approximately 450 kilometers. These are close to each other but far away. Okay, 450 kilometers on the surface of Earth. Here also geographic south and magnetic south are not the same point, it is little bit different. Now what is this axis called as? Geographic axis. The axis that connects geographic north with geographic south. Now what is this axis called as? Magnetic axis, and the one which connect magnetic north with magnetic south. Now this angle when we measure, that is angle in between geographic axis and magnetic axis, when we measure, the angle is found out to be 11.3 degree. Now see, this perpendicular to the geographic axis, we draw another line. This is taken as equator. Perpendicular to the geographic axis, another line is drawn. This one is equator. Now the plane, when we are cutting the Earth along the equator, we will get an equatorial plane. This one is the geographic equator. This is geographic equator. Okay, this plane. It will be a circular face. Now from here we will be taking the measurement of angle. This is 0. From 0, 10 degree, 20 degree, 30 degree, 40 degree, and this one is 90. So in between these 2 points the angle is 90 degree. So when we measure the actual value of magnetic north, it is found out to be 79.7 degree, 79.74 degree longitudinal. So longitudinal is measured from here, 0, 10, 20, in that way. Now I can also say that it is 11.3 degree away from geographic north. In which direction? This is north, right? This one is east and this one is west. North, yeah, right side is east and this one is west. Now it is 11.3 degree in west direction, that is magnetic north. So magnetic north is in 11.3 degree west direction from geographic north. Clear? That point is clear. I hope that point is clear with you. Now the very important thing is, why does Earth behave as a magnet? So there are three theories existed before. One thing was, we know that inside Earth we have a large reservoir of ferromagnetic substance, that is iron core. So initially we thought that this iron core is producing the magnetic field, but then we have learned about Curie's temperature, and we know that at such high temperature, inner core is at very high temperature, and for iron the ferromagnetic temperature, Curie temperature is nothing but 1043 Kelvin. So that is a lower temperature as compared to the inner core of Earth. So at such a high temperature inside at the core of Earth, this ferromagnetic substance will behave as a paramagnetic substance, and that won't be sufficient to produce the magnetic field which we are experiencing. So later different theories have came, and the one which we are following is in this way, that is at high temperature this inner core will be in liquid form. We know about lava and all, right? So it will be in liquid form, and that will be having lot of ions in it. Ion means charge, positive charged ion and negative charged ion. Now let's say we have a positive charged ion here. Now at the same time Earth is rotating in its own axis. So basically it is rotation of positive charge around an axis. Now charge is moving about an axis. So that can produce a magnetic field, right? So instead of an iron core inside, what producing magnetic field? It is ions in the liquid core that when rotates about its own axis, that is along the axis of, along the rotation of Earth, these charges also will be rotating on the axis, around the axis, and that will be producing a magnetic field. So this charge when they rotate, that is producing a magnetic field. So the black color one. But one more confusion we do have. See, so far we have learned the north will be attracted by south, right? But when we are keeping a magnet, its north is pointing towards the Earth's magnetic north, right? What is the reason for it? Basically it was supposed to repel, right? See, as it is closer to geographic north, we are just calling it as magnetic north. Basically inside, if you are considering a magnet, so in red color I am going to mark inside, when we are considering a magnet inside Earth, it will have its south pole here and it will have its north pole here. So when we consider the Earth as magnet, we will fit a magnet inside Earth where its south pole will comes along the direction of magnetic north, and its north pole will come along the direction of magnetic south. We are just calling it as north and south because it is nearest to geographic north and geographic south. But basically when we consider it as magnet, its south and north will be in this direction. Okay, now when we are keeping a magnet on the surface of Earth, its north will be pointing towards the magnetic north, but basically it is south here. But we won't mention this south anywhere, okay, it is pointing in this direction. And that is all about Earth as magnet. Now in the next video, we will learn about declination and angle of tip. That is very important. We will learn it in the next video. Thank you.